Hello, today I like to show you the difference between Roga Instruments DAQ devices and standard data acquisition PCBs or devices which used very oftenly in the industry. The main difference between these devices and the Roga Instruments devices is that Roga Instruments DAQ devices use in general ADCs with the delta sigma modulator. So it means we calculate always automatically the anti-aliasing filter. Now I like to show you what does it means. I have here both devices connected to the PC, and for this demonstration I use here the DaisyLab program. The nice feature of DaisyLab is that I can use here the plug-in DAQ Lite as input and this multi-channel DAQ card, which is relatively good for budgetary situation. So we have here the output. Here we have a digital filter, but this digital filter is at present disabled. So then we have here the display. So means we see here an RMS value, the value, how many millivolts we have. Then we have here the YT chart. This is this from plug-in DAQ Lite and from this DAQ card. Here we go to the sound level meter calculator, so for dB calculation, and here we go to the FFT display. So this FFT is in dBs relative to 20 micropascal. So that means our 0 dB reference is at 20 micropascal, so for microphone people. But it doesn't matter now for this demonstration. So now I run the application and just show you that if I remove this here, so then the lower channel will disappear. If I disconnect this one, so then plug-in DAQ Lite don't see the signal yet. So now we have here from left, or from plug-in DAQ Lite and from DAQ card, the signal at 94 dB. So now I will do following. I will increase here the frequency. Let's go to 10 kilohertz. So this is now 10 kilohertz. Now I can go straight ahead to 20 kilohertz. Now I go to 21. So at 22 kilohertz we can see here that at the channel number 1 the anti-aliasing filter already is active from plug-in DAQ Lite. From this card there's no change. So now I go to 25 kilohertz. Now you can see it's the signal from plug-in DAQ Lite is no longer available, and here's a high damping. But from this DAQ card we can still see here full energy, close to 94 dB, and we see here a kind of a shadow or illusion frequency. So this is the aliasing effect. So it is a kind of a digital illusion or a digital mirage. So now we can say, okay, I have digital filters. Good. So now let's activate the digital filter. I make this here low pass filter for 20 kilohertz. And this channel, this is now for the DAQ card, exactly same setting. So the signal is still here. So that means this digital filter don't have any effect to suppress the aliasing. So even I adjust now a higher frequency. So, and if I don't have the delta sigma ADC or in front here of this input analog filter, so then I measure always some wrong signals. So let's assume you can say, okay, but my sensor, like microphone or accelerometer, have a linear frequency up to 10 kilohertz or up to 20 kilohertz. Yes, that's correct. But the sensor still can measure something above this frequency. It is only not so linear anymore as before. So because it is specified, let's say from 5 Hertz to 20 kilohertz, but the sensor get also still some data above 20 kilohertz. So in many cases, the effect is that you measure signals above the Nyquist frequency, which are mirrored down to the lower frequency bands. So now I can go to higher frequency, and now I go to 29 kilohertz, and now you see that the sinus, the peak, yeah, go now into the lower frequency. So this is the aliasing effect. So, and in case of our plug-in dark light, there is no signal illusion. So, and here again, it means that this kind of digital filter have here no effect, because the digital signal is here already wrong interpreted due to the absence of the analog anti-aliasing filter, or due to the absence of the delta sigma modulator inside of the ADC. So that's all for today. Thank you very much and have a good time.